Let's solve this inequality in one variable. So let's notice that we have x on both sides of our inequality. So this means we want to get our x's together. But before we do, we're going to need to simplify the left side. So let me review again. We're going to use GEMDAS. And I've got stuff that needs to be cleaned up on the left. So that means I'm going to go in a normal direction, and I'm going to simplify the left side. So that means that this -2 is going to be distributed or multiplied into the parentheses. Because when I'm looking here, G means grouping. So I look inside my grouping and I cannot simplify 3x plus 1. That is what it is. There are no exponents, so the next thing is multiplying, and that's what's happening between the -2 and this parentheses. So that gives me -6x minus 2 is greater than -6x plus 7. Okay? I cannot simplify the left, I cannot simplify the right. So that means I'm going to now do GEMDAS backwards because I'm going to solve for x. So the first question I ask myself is anything being added or subtracted to the x term? And the answer is yes. What is being added or subtracted to the x term? Well, here's my x term, and here's also an x term. Okay? So on one side, I have a -2, and on the other side I have a 7. So one of these is going to need to become a 0, because if something's being added or subtracted, I want to turn it into a 0. Let's go ahead and get rid of this -2. So I'm going to add 2 to both sides of the inequality. So that gives me -6x, that becomes a 0, so I don't need to write it down, minus 6x plus 9. Okay, so if I were to then try to get rid of this and put it over the other side, it would be stuck with the x term over there. So what we're going to do now is we're going to kind of abandon this whole idea, and we're going to do what's the reflexive property, which is what we did when we added 2 to both sides. I want to get rid of this -6x and bring it over to this -6x. So because my term is being added to something, I have to do the inverse, which would be adding 6x. So this becomes 0, because -6x plus 6x is 0 x's, is greater than, well, this becomes 0, 9 is what I have left. So this is weird, my x's disappeared. So what does this mean? Is 0 greater than 9? This is so not true. Okay? This is not true. So since we get a not true statement, that's equivalent to no solution. Okay? No solution. So what does that mean? As far as graphing, we do not put anything on the graph because we have no solution. Set builder notation, there's no solution, so we're going to say null set. We could say where x is null set. The set such as x is null set. Interval notation, we don't have anything, so we can just say simply null set. There's nothing in there. Okay? So when I say null, this is the word I'm using. Null set, meaning empty. There is nothing in that set at all. Let's look at another inequality in one variable. We're going to use the same principle again. We're going to use the GEMDAS. Okay, I want you to start thinking about this. When we look on the left side, it's pretty busy, a lot of stuff going on there, which means we have to simplify first. We're going to simplify before we solve. So again, what do I have going on here? Well, there's some multiplication happening right here. nothing I can do inside the parentheses, which is our grouping symbol, but I can multiply 5 to 2x, which gives me 10x, 5 to negative 3, which gives me negative 15. Nothing is happening to that negative 7 because it's not in the parentheses. So I bring that at negative 7x less than or equal to 3x plus 8. I can still do some cleaning up because if I notice, what do I have on the left? I have an x term and an x term. So I can combine those two. So I have 10x minus 7x, which gives me 3x. And then I bring down the 15. So that cleaned up that side. Is less than or equal to 3x plus 8. Okay? So now I have both sides of the equation as simplified as possible. So then that means now I'm going to solve. And when I solve, I do GEMDAS backwards. So again, I come to my adding and subtracting. So I ask myself, is anything being added or subtracted to the x term? And the answer is yes. So I have a choice here. I either make this negative 15 turn into a 0, or I make the 8 turn into a 0. I have a choice. Okay, so it really doesn't matter which way I go. So let's get rid of this 15. So I'm going to add 15 to negative 15, which means I have to add 15 to 8. So this leaves me with 3x is less than or equal to 3x plus 23. Okay, so just like in the other situation, if I were to then go through this whole GEMDAS thing again and subtract the 23, I would end up putting it with this 3x over here. And I would be doing that forever. So at this point, I have to realize I'm going to use the reflexive property, which means I want to get this 3x over to the other side. I'm going to subtract it, so what I do to one side I do to the other. So then 3x minus 3x gives me 0. 0 is a quantity, I have to write it down. Is less than or equal to 23. So is 0 less than or equal to 23? The answer is always. There is never a time when 0 is not less than 23. This is always true. Okay? So if it's always true, that means our answer is all real numbers. I'm going to use the pound sign to represent numbers. So when we get it always true, it's all real numbers. So what does that mean as far as our number line goes? I'm just going to mark a 0 here. So if I were to put 0 in for x, then I would get this. Let's just look at this. This 10x would become 0. This negative 7x would become 0. And this 3x would become 0. Which would mean negative 15 is less than or equal to 8. Well, that's true. I can pick any number I want, and that would be true. So in order to say all real numbers on my number line, I am just going to draw a line over my number line. That means everything. So how do I do this in set builder notation? It's a set in which we have all real numbers. The set of x such that x is all real numbers. So we're just going to put that fancy R there. Interval notation. We're going to look at our number line. Well, the smallest number I can possibly have is negative infinity. And the largest number I can possibly have is infinity. Which means for interval notation, I'm going to start at negative infinity. I use the parentheses because I can never equal negative infinity. And I go all the way to infinity. So that's interval notation. So this is when you've got some funny stuff going on. When you get not true means no solution, and always true means all real numbers.